I want to point something out here, that the risk of project failure tends to vary quite a bit, as you'll see if you look at his book, Estimating Software Costs. So the value of the information for testing goes up dramatically as the project gets large and complex. Okay, so let's assume that basically we've got a medium-sized project. We're going to reduce the risk through the information generated by testing at 10%. Let's assume that the project cost is the only value that's at risk, which is basically meaning we're ignoring the opportunity cost associated with a project failure. And say, well, if the project fails, we lose all the money that we spent on the project, which is certainly true. So we're going to take the testing budget, the development budget, which are collectively $330,000, and we take 10% of that, so that's the value of the tracking information. So, and take that $33,000 and throw that in the mix here. So I've done that down here. So again, a relatively small incremental increase. Across these other three values, we've captured less than $100,000 as compared to $500,000 plus of benefit from just the bug tracking. So that's fairly typical that the bug tracking value is going to be the most significant of the values. But still, worth keeping in mind that there is some significant value associated with these other areas outside of bug detection. Now, our overall percentage return on investment here, you see, is 738%. You might say, okay, well, how's that compared to the real world? Fairly typical number is 800%. There does tend to be tremendous variation in this when we measure it. And we've seen it, down in the 30–40% range, as low as, and as high as in the 3,200% range. So it does vary quite a bit. 800 is pretty typical. So this, while a hypothetical case, is not unusual in terms of the actual number that we see. But, hypotheticals are all well and good. Let's look at an actual case study. Now, this is from a project that my colleagues and I did a few years ago. Let me just try to find this. Shoot. Oops. Bear with me for just one moment here. We're gonna find this spreadsheet and get it open. Okay, yeah. Now, yeah, all right. So you should now see, refreshing on your screen, a spreadsheet. This, by the way, is described in great detail in an article. So it's out on the on the basic library or the articles page, one of the two, as a case study in calculating return on investment of testing, and this is described here. So let me walk you through the calculation of the return on investment just for the finding of bugs, must-fix bugs. Okay, so we have the budget for testing. It's $1 million. This is a number that I know. This is the number that was actually spent on testing prior to release. About 10% of the testing effort was spent building test tools and test frameworks and other stuff that had reusable value for the future. So we're going to deduct that out here. This is a form of amortization, basically, and take that out. So that's a long-term asset that was created. We're also going to take out regression test costs. Now, in this case, this is a greenfield development, so all the regression testing was basically retesting functionality that had already been tested in that project but had to be retested due to the extent of changes that occurred. That's a cost of internal failure, so we need to move that somewhere else. So just the detection cost is $1 million minus 100,000 minus 500,000, or 400,000. That's our net detection cost. Now, we found 1,500 must-fix bugs before testing, and that means that our approximate cost per bug is $267 per bug. So that's just 400,000 divided by 1,500. Okay, now internal failure costs. A couple things here. First, let's do the easy one. The regression test costs, right? That's just the same number that was up here, moved down there because it's an internal failure cost. And then there were 30 developers during the 3-month system test period that were doing pretty much nothing but fixing bugs. And so assuming a fully burdened salary rate of $100,000 per year, which was fairly typical at that time, that gives us $750,000 in bug fix costs. Now, this is something that's worth pointing out, that notice that some of the costs of internal failure are not testing costs; they're development costs, and that's going to be that's going to be typical. You're going to need to account for that. So you need to have some way of estimating the amount of developer effort associated with the internal failure. So our net internal failure costs, $1.25 million. Take $750,000 plus the $500,000. Again, must fix bugs found prior to testing, 1,500, or found during testing, excuse me. So our approximate cost per bug is $833. Okay, so our total cost for bug found during testing now would be the cost of detection plus the cost of internal failure would come to $1,100. So notice that as long as the cost of an external failure is greater than $1,100, we've broken even or better on our testing. So that's good. Now let's see if we can figure this out. So sustaining costs in the first 6 months prior to release, the organization spent about $3 million. Sorry, the first 6 months after release, the organization spent about $3 million on sustaining costs. So that's developers, testers, and tech support people. And according to my discussions with the client, about 50% of that was bug related, and the other 50% of the sustaining cost was adding new features. So that means that our external failure costs are $1.5 million. Notice that to do this, you'd have to know the size of the entire team supporting the release, supporting the product, and you have to know about what percentage of the effort is bug related, and then you want to avoid assuming too long a period of value. You know, you got a rapidly evolving product, and it's going to change pretty substantially within 6 months to a year. You know, you don't want to try to count a lot of value of saved cost of external failure after that initial period is up. So that's why I assume 6 months, and so you want to have a discussion with people about